All right, chapter 11, nutrition and physical activity. So, first of all, let's start out with defining some terms for this chapter: physical activity, exercise, and physical fitness. And I wanted to the part one, we'll talk about how energy is used in the muscle, the amount of, or kind of go over that whole Krebs cycle again, talk about ATP, and kind of just break down some terms. In part two, we will look at specifically nutrition recommendations for athletes, and then physical activity recommendations for just the general public. So, all right, so physical activity, this is movement that is due to or the result from skeletal muscle. So remember, skeletal muscle are one of the three types of muscle that we've gone over. Skeletal, smooth, and cardiac are the different types of muscle. So physical activity is movement that results from skeletal muscle contraction. Exercise is pretty much any planned and purposeful movement. And then physical fitness is your body's overall fitness, like how fit are you? And we have different ways to measure physical fitness. So more objective measures. It's your body's way of determining, are you fit enough to conduct this particular activity? When we look at some more terms: healthy adults under the age of 65, and this is in general, okay, whether you're an athlete or not. Moderate intensity is, uh, moderate activity is recommended. Intense physical activity for at least 150 minutes per week. So it's recommended that most people be moderately active, and that's 150 minutes per week. And what I used to tell my clients is just any movement whatsoever, just move your body, move your beautiful body at least 150 minutes per week, because for a lot of people, just that right there is a great accomplishment. Or you see how it's further defined here is vigorous intensity and strength training. And this is what's most recommended, vigorous intensity. And we're going to talk about how you measure that, as far as heart rate and all of that is best. And notice how it's fewer minutes here. Excuse me. And strength training, so crucial with building bone health and skeletal muscle strength and so forth. So if you had to choose, moving your body, obviously number one, and number two, getting that strength training and intense physical activity. When we look at the benefits of physical activity, oh my goodness, it's you know, multitude. It is, as you see here, it improves sleep, it improves well-being, it improves muscle mass, overall health, reducing free radicals, blood sugar. So really, it is the improved immune system. 100% your whole body benefits from movement. Okay, a body in motion wants to stay in motion. A body in motion is healthier. Okay, and the more you move, the more you want to move. And I would always tell my clients, you never want to, there again, in general, my history with nutrition was patients, not with athletes. Okay, so I am not an athletic trainer. I am not an athletic dietitian, but for the general population and most of the clients that you will see, unless you go into actual um, uh, athletic training, most of the patients you're going to see are going to need just motivation in general, okay? And just getting them up and moving in any way is 100% beneficial. And no matter their age, whether they're a child and a young adult like you guys are, middle-aged or elderly, just get them to move. So let's look at some of those further guidelines here when we talk about intensity and how we measure that. So when you look at uh, subjective measures. Intensity of exercise refers to exertion level, and this is usually based on physical signs. So, can you talk while you're walking, your breathing rate, your overall ability to continue that intensity? You can kind of tell whether you're in that uh, by your breathing and able to carry on a conversation if you're reaching your particular level of intensity. We can also measure it here. And you see here by calculating your age-related maximum heart rate. So calculate uh, 220 beats per minute, excuse me, here, and subtract your age from that. Okay. So a 20-year-old person's age-related maximum heart rate is 200. So you take 220 beats per minute and then subtract your age. And this gives you your uh, number where we're going to kind of define moderate versus vigorous. Okay. Are you within that target heart rate zone? Now, and we'll talk a little bit more here about your Apple Watches and your Fitbits and those kind of things. And these are really good as far as motivating people and helping them, to do those percentages and those math, that percentage math that we talked about right here. Are you 64 to 76% within your target heart rate zone? That's moderate intensity. And are you 77 to 93? Related to your age maximum heart rate here. So those Fitbit things really do help to calculate that for you. But it's a quick way of just measuring your radial pulse, and you can calculate that yourself. And it is fun to do, and it's kind of satisfying to make sure your effort you're getting the maximum out of your physical activity effort. And this is a cute little uh, physical activity guide on page 435 of your textbook that talks about where most Americans are right here, sedentary. Okay. And we need to be definitely down here on the base. So, like I said, getting your patients to at least, get up and do something several times a week is ecstatic. That's wonderful. But in order to get that long-term benefit, that physical fitness intensity, and to be quote unquote physically fit that we talked about earlier, you need to be down here. Moderate activity, aerobic activity, strength training, those kind of things, most days of the week, as you see here. So let's talk a little bit about that, the different types of activity. You have aerobic strength and flexibility. Remember, aerobic gets you into that target heart rate zone. So that builds heart rate. Strength training, this is with weights and resistance. Okay, activities that are going to build muscle mass and that bone density mass. And then your flexibility exercises, your yogas, your uh, well, Pilates, I guess, would be a little bit of both flexibility and strength, but there's a lot to be said about flexibility and stretching and overall balance. Okay, as people get older, understanding and maintaining their balance while in motion is critical. So, flexibility exercises really do help that. And things like yoga and Pilates, in addition to your jogging, your swimming, your weightlifting, those kind of things, are just as crucial as far as that balance that I talked about earlier, and mental. I see a lot of benefits from patients who love that mental benefit of kind of slowing down and meditating a little bit during their exercise, finding that purpose. So when we look at how the body uses, or let's focus on cells for just a moment and look at how this movement and these exercises are possible with the body using ATP. So kind of a review of some of your uh, basic biology classes. So where does the energy come from? The cellular energy to perform these activities. We talked about how your body uses ATP, needs it for muscle contraction. And the way it does that is through this process here. It's think about it as a rechargeable battery in a way, how the muscles are able to reset by using ATP. And you see here when a cell needs energy to drive that chemical reaction, which is muscle contraction, it's going to use, um, you see these enzymes here, the enzyme to break down these chemical to break down this bond here between the last two phosphate groups, and you end up having ATP, which is energy, being released and reforming this ADP into ATP. So energy reserved here in the bond gets turned into ATP again and again and again, and that's that cycle. When you look at it here at the cellular level again, we look at that process of glycolysis, okay, glucose, which is why the body loves to run off of glucose. It can be broken down or catabolized under certain conditions that are anaerobic or aerobic, which is good, but anaerobic for a limited amount of time. You see here the first stage of glucose oxidation or glycolysis is breaking down a glucose molecule to form these two pyruvate molecules and a small amount of ATP. And if oxygen is available, okay, which the body loves, each pyruvate then further undergoes oxidation in the mitochondria here. It moves, excuse me, from the cytoplasm into the mitochondria. And um, which the mitochondria is the powerhouse of the cell. And it is from that more ATP in the mitochondria you see here is made, and then a little bit of water, a little bit of waste and CO2. And that is how muscles are able to get their overall energy that they need in order to provide the daily functions and especially the athletic training functions in exercise. So what does ATP need? You see here summary of ATP formation. It comes from a good healthy diet. Okay, we've talked about that proportion of fat, carb to protein, and you see here why each is essential. Amino acids from proteins, glucose in amounts here. Yes, and we'll talk a little bit more here about glycogen stores in a second, and then of course how fat is essential. The body uses three major um, energy systems, can make ATP in these three ways. And let's briefly talk about each one. The first system is this phosphocreatine system. It is not very well, it works, but it's not as efficient because it's quick and not long term. As you see here, it lasts for about 10 seconds. The second system here is your lactic acid energy system. This is in anaerobic conditions. Um, the body is able to convert this pyruvate, which we talked about before, and then into lactic acid, which ultimately um, gets converted back into glucose, part of this Cori cycle. Um, and you see here where lactic acid here in the liver. uh, If the body doesn't need the energy, then it's going to use that to store glucose and change that to glycogen here. That type of glycogen storage we talked about a little bit earlier and how the liver is important there. And then the third stage, or the third system, excuse me, for ATP, oxygen aerobic energy system. So this is what is most efficient. Okay, it's 18 more times efficient in producing ATP than anaerobic conditions, which we talked about earlier in that phosphocreatine system and the lactic acid system. Okay. This was a fun activity I used to do with my high school students. We would calculate their VO2 max. And so this is a way of being able to calculate the uh, uh, the maximum oxygen intake during vigorous physical activity because you can only take in so much. Your heart can only pump so fast, your lungs can only take in so much air. So it's how much oxygen into the bloodstream and into the lungs at any particular time. So it's a nice calculation to do. And I think the textbook gives you that calculation to do that, or you can plug it in and calculate it out. It's kind of fun to do. And then also, I love this slide too because it compares fat or carbohydrate for exercise fueling. Um, so there again, fat is the primary fuel when the body's at rest, so low to moderate activity. And there again, most of your patients, most of your average American population does not need to carb up, does not need to carbohydrate load. We'll talk about that in part two, about how we do that. But there again, notice this term high intensity. Okay, unless you are an athlete, unless you are working out for hours and hours and hours and hours a week, um, most people aren't at this high intensity level. Okay, they're at the top two tiers of that exercise pyramid we talked about before. So, protein, yes, fat, yes, carbohydrates in moderate amounts, never too much. There again, training and how you exercise and the amount of training you do is going to depend on the amount of carbs you need. Okay. So you see here, this is exactly what I was talking about. Most average people who are just trying to get into the daily routine of exercising don't need to carb up. Okay. We're talking about your professional athletes, your long-term endurance athletes, your sprinters, those kind of things where that immediate burst of or that immediate depletion of glycogen stores is where you're going to need that burst of energy. In part two, we'll talk more about how to estimate needs. We'll look at specific athletic performance and carving up energy bars, energy drinks, sports drinks, those kind of things, and look at some heat related illnesses. So I'll see you back in part two.